Hello everyone and welcome back to my channel. Today we will start a new lecture series on digital logic design, which has a wide application in engineering and also in real life. The contents of today's lecture are Introduction to Digital System and the type of signals. Then we will study number systems, which include binary numbers, decimal numbers, octal number and hexadecimal number. And then we will study how to convert a number from one number system to another number system. We know that life without digital system will be much difficult these days. And the digital system have wide application in communication system, business transaction, traffic control, spacecraft, and to many other fields are connected directly. These days, most of the people have digital computers or laptop, which are also widely used for scientific purpose, industrial purpose, or to manage business records. Now, if you further look at telephone exchanges, digital camera, electronic calculators, TVs, so the most of the things around you are made up of digital systems. Now we will study the signals through which these systems are operated. Signals are widely divided into three categories. First one is analog signal, second one is discrete signal, and the third one is digital signal. Now the analog signals are those signals which can take any amplitude value and are defined for any instant of time, where the discrete signals are those signals which can take any value of amplitude but are defined for the discrete values of time. And in last, the digital signals are those signals whose amplitude is also discrete. Now if you look at figure 1, the signal in blue line represents an analog signal or a continuous time signal, which is defined for the all values of time. And the signal in red lines represent a discrete signal which is defined for only discrete instant of time. And you will observe that in one cycle there are only 20 values of discrete signal. Now if you look at figure 2, which represents a digital signal, the signal is defined for a discrete instant of time and its amplitude is also discrete. The digital systems are mostly operated with digital signals, which are defined for a discrete instant of time and their amplitude is also discrete. Number system. In this chapter we will study binary number system, decimal number system, octal number system and hexadecimal number system. And later we will study how we will represent a number from one number system into another number system. Now we will start with binary number system, whose base is equal to 2 because it have two digits, which are 0 and 1. And these digits are known as binary digits or bits. Now if you look at example, we have a binary number which is 101.01. A number will be represented in close parentheses with a base. Here we have a base of 2, which represents a binary number system. Now if for a given number we want to find weight of each bit, we will use the relation base power position. Now for the given number 101.01, we will start assigning positions. All the numbers to the right of the decimal sign, we will start positioning from -1, -2 and so on. And for all the numbers to the left of the decimal sign, we will start numbering from 0, 1, 2 and so on. Then using the relation base power position, the weight of the first bit to the right of decimal, which is 0, the weight is 2 power -1 or 0.5, and the next bit 1 have a position of -2, so its weight will be 2 power -2 or 1/4. Now for the bits to the left of decimal, the first bit is 1, so its weight will be 2 power 0 or 1. Next bit is 0, its weight will be 2 power 1 or 2, and the next bit is 1, whose position is 2 and its weight will be 2 power 2 or 4. Now to find the magnitude, we will use the relation sum of bits into weight. We will multiply each bit with its magnitude and then we will sum the result, and we will have a number in decimal form. In this case we have 5.25 to the base 10. The next is formal representation. For formal representation, we will enclose a given number in close parentheses and in subscript, base of the number system will be written. In this case, we have a base 2. Now few terms related to the group of bits. If we have a group of 4 bits, this group is known as nibble, where if we have a group of 8 bits, this group is known as byte. If you look at examples 1011, which is a group of 4 bits, this will be a nibble, and in next term we have a group of 8 bits, this will be known as byte. Now the next number system which we are going to study and is most commonly used is decimal number system. This number system have a base 10, or also known as radix, because it has 10 digits starting from 0 up to 9. This number system can also be used to represent numbers in fraction. In the given example, we have a number 512.74, which is represented in decimal number system. The position of every digit defines its weight, and the relation which we will use to determine the weight will be base power position. First of all, we will assign numbers which we'll use to represent a position, and then we will use the relation base power position to find its weight, and for magnitude we will multiply digit with its weight. We will start numbering from -1, -2 and so on for digits to the right of the decimal point, and we will assign numbers 0, 1, 2, 3 and so on for all the digits to the left of decimal sign. For example, first digit to the right of decimal point is 7. It will have a position of -1 and its weight will be 10 power -1, which is 0.1. Second digit is 4. Its position is -2, so its weight will be 10 power -2 or 0.01. Similarly, first digit to the left of decimal point is 2. Its position will be 0 and its weight will be 10 power 0 or 1. Next digit is 1. Its position is also 1 and its weight will be 10 power 1 or 10. And we will repeat the same process for all the upcoming digits. Now to find magnitude of whole number, we will multiply each digit with its weight and we will sum up the result. And we will have a result of 512.74 to the base of 10. Here base 10 represents that the given number is from decimal number system. The next number system which we are going to study is octal number system, and it has a base of 8 because it has 8 digits starting from 0 up to 7. And here also the rule of weight is same, which is followed by a formula base power position. In the given example, we have an octal number and we will convert into a decimal number system. First of all, we will assign position to every digit in given number. We will start position number -1, -2 and so on, which are to the right of the decimal point, and the position number starting from 0, 1, 2 and so on to all the numbers which are to the left of decimal point. For example, the first digit in the right of decimal point is 7. Its position will be -1 and its weight will be 8 power -1. 8 is the base of number system. Then next digit is 4. Its position will be -2 and its weight will be 8 power -2 or 1/64. Similarly, for the numbers to the left of the decimal point, first one is 2. Its position is 0 and its weight will be 8 power 0 or 1. Next digit is 1. Its position will be 1 and its weight will be 8 power 1 or 8. And we will repeat the same process for other digits. Now to find the magnitude, we will multiply each digit with its weight and we will sum up all the results and we will have a number in decimal number system, which will be 330.9375 to the base of 10. And this number is obtained by converting given octal number 512.74 to the base of 8 into a decimal number system. The last number system in this series is hexadecimal number system, and it has 16 digits. Hexa means 6 and decimal means 10. So to the 10 digits of decimal number system, 6 additional digits are added and a new number system is formed known as hexadecimal number system. The decimal portion starts from 0 and ends on 9, where hexa part starts from A and ends on F. The remaining rules are same, that for a given number in hexadecimal number system, the position of a digit represents its weight. In the given example, we have 1E5.7a, a hexadecimal number system, and we wish to represent it in decimal number system. So first of all, we will assign position to every digit, and then we will use the relation to find weight, which is base power position, and then we will determine magnitude by multiplying digit into its weight. So the rules of position are same. We will assign position numbers -1, -2 and so on to all the digits which are to the right of the decimal, and then we will assign position numbers 0, 1, 2 and so on to all the digits which are to the left of the decimal point. In the right of decimal point, first digit is 7, its position will be -1 and its weight will be 16 power -1 or 1 over 16. Next digit is A, its weight will be 16 power -2, which is 1 over 256. Similarly, to the left of decimal point, first digit is 5, its weight will be, its position is 0 and its weight will be 16 power 0 or 1. Next digit is E, its position is 1 and its weight will be 16 power 1 or 16. And the same assignment will be continued. Now to find magnitude, we will multiply each digit with its weight and then we will sum to find a number in decimal number system, which in this case is 485.4765625 to the base 10. And this is conversion of 1E5.7a to the base a hexadecimal to a decimal number system. Thanks for watching the video. This was all about today, and stay connected for more interesting videos.